In this video, I'm going to look at laws of indices, simplifying expressions that contains fractional indices, and solving equations involving indices with unknown power and unknown base. So let's get started. I have some notes here. So we're going to start with the multiplication law. So the multiplication law of indices states when multiplying indices that have the same base, add the indices or powers. So I have an example of what the statement means here. Here, if you're given two indices which are multiplied, let's say a power m multiplied by a power n. So the bases are the same. These are the bases. So you have to add the powers, which is the m plus n. This is the answer here. Let's say you're given to multiply 2 power 4 and 2 power 3. So the bases are the same. So you have to add the powers, which is 4 plus 3. That will give you a 7, and the 2 raised to the power 7, it's 128. So that's it for the multiplication law. Now let's look at the division law. The division law states when dividing indices that have the same base, subtract the index or power. E.g., I have an example here. Let's say you're given b power 3 divided by b squared. The law of indices of division states that when the bases are the same, so this b and the b, the base are the same, so you have to subtract the powers, which is the 3 and the 2. So 3 minus 2 is equals to 1. So b raised to the power 1 is the same as b. So here the second example, which is 2 power 4 divided by 2 squared. The bases are the same, so you have to subtract the index. So 4 minus 2 is 2. So 2 squared is 4. So that's it for the division law. And now next we have the raising powers. So the first one states any number or letter raised to the power 0 is 1. So any number, be it 1000 raised to the power 0, it's 1 or later. So I have an example here. 10 raised to the power 0 is 1. T raised to the power 0 is 1. The next one, it's any number or letter raised to the power 1 is that number itself. Any number, for example, 20 raised to the power 1 is 20, and t raised to the power 1 is t. The last one, which is any number raised to a negative power is the inverse of that number. So here I have an example of what this statement means. Let's say you're given 2 power negative 1. This means the inverse of 2. So the inverse of 2, it's half, which is 1 over 2 power 1. So another example here, I have when you're told to find the 2 power negative 3, the inverse of 2 power negative 3 is 1 over 2 cubed. So that's it for this law. Now let us look at the examples on how to deal with these laws. I have an example here. It's 5 power 2m minus 3n multiplied by 5 power 2n minus 2m. So for this example, we are going to use the law of multiplication. So this will equal, so the law of multiplication states that when the bases are the same, you add the powers. So our base is 5, we are going to maintain it. So the power, we're going to add them. So 2m we group the like term, so we get this m minus 2m minus 3n plus 2n. So 2 minus 2, that's 0. So negative 3n plus 2, it's negative n. So this is going to equal 5 power negative n. And our last law here state that any number raised to a negative power is the inverse of that number. So we have to write the inverse of this. So this is going to equal 1 over 5 to the power n. That's it for this example. So here is example 2. We have to simplify p multiplied by p cubed divided by p power 4. So this one we're going to follow the law of BODMAS, which is brackets of division, multiplication, addition, and subtraction. So we're going to start with the part here where there is division. So this one here, we're going to drop this p and the multiplication sign in the brackets. It's going to be the law of division states that when the bases are the same, you subtract the powers. So p, the bases are the same, so p minus, so this is 3 minus 4 p. So 3 minus 4 is negative 1. So this equals p negative 1, and the law of multiplication states that when the bases are the same, you add the powers. So here the bases are the same, so it's going to be 1 plus negative 1. So here it's negative, so 1 minus 1, it's 0. P equals 0. So any number or letter raised to the power 0, it's 1. So this equals 1. That's it for this example. Let's go to the next one. So here's the next example. So 3 squared multiplied by 3 power 0 times 3 to the power negative 2. So here this is going to equal 3, since the bases are the same for these two. And for this one, now here there is a negative, so we have to take the inverse of this. So it's going to be 3, 2 plus 0 multiplied by the inverse of this, which is 1 over 3 squared. So this is going to equal 3 squared multiplied by 1 over 9. So 2 squared is 9 over 9. Then these cancel out. When you divide them, it's 1. So it's going to equal 1. So let's go to the next. So our next subheading is simplifying expressions that contains fractional indices. So I have an example here. There's 8 power 2 over 3. So for this one here, you have to take this. This is the same as so this, the denominator of the fraction, which is the 3. When you see a fraction, when you're dealing with indices, you have to introduce the root symbol. So the denominator, which is 3, it comes here. So the power, then you write the 8, and the power like this. That's how it's written. You can also, if you wish, you can also write it like this. It's the same. Eight squared, like this. It's the same. Either way, the answer is the same. So the next one, it's the next example is 8 over 3. Now the power here, it's negative. It's the same question. Now for this one here, the power is negative. So as the law states, so this one is going to be 1 over, so the 3, which is the denominator, comes here, and the 8 on the middle, and then you square it like this. So that's it for this question. The next one, and when simplifying for this, I forgot to finish this one. When simplifying it, you first take the cube root of 8. The cube root of 8, it's 2. So 2 squared is 4. Forgot. And for this one, it's going to equal 1 over the cube root of 8. It's 2, and 2 squared is 4. So this one is going to be 1 over 4. Have you seen that it's the inverse of the answer which was on top? So the last question on this, it's a 3 power 0 plus 1 over 4 power 1 over 2. So for this one, any number raised to the power 0, it's 1. So this one is going to be 1 plus 1 over, and we introduce the square root, the 2. It comes here, so we don't write the 2 here. This is already known that it's a square root. So 4 power 1, which is the same as 4. So the square root of 4 is 4. Oh, the square root of 4, it's 2. And 1 plus 1, it's 2. Then 2 divided by 2 is equal to 1. So that's it for this example. Okay, here is an example 2 on the same subheading. So for this question, we're told to simplify this. The fourth root of inside of the fourth root, there's a 3 power a multiplied by 9 power a plus 1 over 2 or 27 power a plus 2. So for this one here, the first thing which you have to do, from the previous example where I told you that the number which is here, it's the denominator. So for this one here, I'm going to first rewrite this as 3a multiplied by 9a plus 1 over 27a plus 2. So this is raised to the power 1 over 4. It's raised to the power 1 over 4. So this whole thing, this whole expression is raised to the power 1 over 4. And when if you evaluate this, the fourth root will come here. So it's raised to the power 4. So now inside the brackets here, let us now reduce the bases so that they are the same. So 3, it can be reduced 3, it can be reduced 9. When we square 9, we have 3 as a base, and when we cube root 3, you have the answer, which is 27. So we can reduce them to 3. So it's going to be 3 power a multiplied by 3 power 2a plus 1 over 3 power 3 open a plus 2. So this question is a combination of the multiplication and division law. So the over here means division. Yeah. Now, since the bases are now all the same, we have to add the powers for the multiplication and subtract the powers for the division. So here this is going to equal 3. So a on top, it's multiplication, a plus, so when you distribute the 2 inside the bracket, it's 2a plus 2. Then division, you subtract, so minus open bracket. On the bottom here, we have when you distribute 3 inside, it will be 3a plus 6. So next step, here, to make our work easy, we can first add this. So this will be 3a plus 2. Then let's distribute the negative into the brackets, so it's going to be minus 3a minus 6. So 3a minus 3a plus 3a minus 3a is 0. So these two cancel out, they add up to 0. So 2 plus 2 minus 6 is 4. So this is 3 or negative 4. So the negative we have to so this power here was supposed to be dropping here, it drops here, it drops, and it also comes here. So now it's 3 power negative 4 multiplied by 1 over 4. So these, when you multiply them, they'll add up to negative 1. So this will equal 3 negative 1, and this is the same as 1 over 3. That's it for this example. That's the answer. So the next question. So here's another example on the same topic. So here we also make the bases the same, since here there is no root symbol. So this is going to be 2n multiplied. So here we're going to reduce them to 2. So 2 power 3 is 8. So n plus 2 over 2 power 2 multiplied by 3n times 2 negative 2n. So the next step is we add the powers. So here it's going to be n plus, when you distribute the 3, to be 3n plus 6 minus you have to be careful. Here there is a multiplication, so here we also do the same. We will use the multiplication law. So the powers, there is 6n plus negative 2n. So next, to make the work easy, we can add this first. So there will be 4n plus 6. Then when you distribute the negative inside, it will be negative 6n. Then this is a negative here, so negative times negative, it's positive, so plus 2n. So let's group the like term. So 4n minus 6n plus 6, plus 2n, and the last one is plus 6. So 4n minus 6n, it's negative 2n. Negative 2n plus 2n, that's 0. So this is going to be 2 power 6, and this equals 2 times 2 times 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So this is the answer for this question. So now let's go to solving powers, with solving equations involving unknown powers. So the next subheading is solving equations involving unknown indices. So I have some examples here. Question is solve for x. Question 1 is 2 power x plus 1 is equals to 64. So for this one, 2x plus 1. So here we have to make the bases the same, just like from the previous example. So here 2 power 6 is 64. So the bases are the same, so we can cancel them out. Then now all we are left with is the powers. So this is going to equal x plus 1 is equal to 6, and when you solve for x, when you isolate x, it will be x is equals to 6 minus 1, and x is going to equal 5. So 5 plus 1, which is 6. Have you seen that they equal? So the next example, here we have 4 multiplied by 5 power x plus 1 close bracket and is equal to 100. So for this one here, first let's divide the 4 which is multiplied to both sides. So here the 4 goes out, then it's going to 5 x plus 1 is equal to 4 divided by 100, it's 25. Then let's make the bases the same. So 5x plus 1 is equal to 5 squared. Then you cancel the bases. Then you deal with the powers. X plus 1 is equal to 2. X is equal to 2 minus 1, and x is equal to 1. So for this one, x is equal to 1, and if you were to substitute 1 here, so 1 plus 1, it's 2. So 5 power 2, it's 25. 25 times 4, that's 100. So it's correct. And for the third question, here we have 125 power x is equals to 1 over 25. For this one here, we have to take this back to the way it was. So this one here, it means the inverse, so which means it had a negative power. So let's raise 25 to the power negative 1. So this is going to equal 125x is equal to 25 raised to the power negative 1. So now let's make the bases the same. So 5 power 3 is equal to 125, and 5 power 2 is equal to 25. So we cancel out the bases, so it's going to be 3x is equal to 2 times negative 1, it's negative 2, over 3 over 3. So x is equal to negative 2 over 3. This is the answer for this question. So if you would like to prove your answer, you can, I will write it here. So this is going to be 125 raised to the power negative 2 over 3. So this one will be 1 over the cube root of 125. Then after that, you square it. So this is going to equal 1 over the cube root of 125 is 5. And 5 squared is equal to 25, which returns you back to the answer here. Have you seen? That's how you prove it. So let me write now the last question on solving equations with unknown power. It's number 4. 10 power x is equal to 0.0001. So for this question here, let's first take this number by the right into a fraction. So it's going to be 10x is equal to, so we're going to count the decimal places, which is 1, 2, 3, 4. So this is the same as 1 over 10,000. So here, this 10,000, as we did for the previous example, we're going to raise it to the power negative 1. So 10x is equal to 10,000 raised to the power negative 1. And let's now make the bases the same. So it's going to be 10 power x is equal to 10 power negative 4. So 10 times 10, 100 times 10, 1000 times 10, 10,000. So now we cancel out the bases. We'll see that x is equal to negative 4. So if we were to put negative 4 here, when we expand it, it will be 1 over 10 power 4, and when you expand the 10 power 4, it will give you 10,000, and when you divide it, it will take you to 0.0001. So let's go to the next subheading. So indices involving unknown bases. Example 1, there is x power 1 over 3 is equal to 9. For this one here, we're going to use the reciprocal. So this, the reciprocal of this is the inverse of this. So this, we're going to, it's going to be x 1 over 3 multiplied by the inverse of this, which is 3 over 1. What you do at the left hand side, you also do it to the right hand side. So it's going to equal 9 3 power 3. So here this will cancel out, it will equal 1. So x is equal to 9 power 3 is equal to 729. The next one, number 2, here 3x multiplied by the square root of x is equals to 81. Here, since there's a multiplication symbol here, so I'm going to divide 3 both sides. So 3 goes, so it will be x multiplied by the square root of x is equal to 3 divided by 81 is 27. So this one is going to be, this one it's this x multiplied by, this one is the same as x raised to the power 1/2 equals to 27. The multiplication law of indices says if the bases are the same, add the powers. So we're going to add the powers. So it's going to be x 1 plus half equals 27. So x 1 plus half is 3 over 2 equals 27. So for this one here, we're also going to use the multiplicative inverse, which is the reciprocal. So we're going to multiply this by 3. Oh, sorry. Let me just write it down. So x 3 over 2 multiplied by 2 over 3. 2 and 2 cancel. 3 and 3 cancel. What you do to the left side, you also do it to the right side, which is 27 2 over 3. So x is equals to 27 2 over 3. So the cube root of 27, then you square it. So x is equals to, the cube root of 27 is 3, then 3 squared is 9. That's it for this question. So let me do now the last question of the video. So for this one, we'll divide 5 both sides. So x power 1 over 2 is equal to 9. For this one, we use the reciprocal, and it will be 1 over 2 multiplied by 2 over 1. You also do the same to the right side, which is power 2. So this will equal 1. X is equals to 81. So that's it for this video. Thank you for watching. Please remember to subscribe and like this video. Thank you for watching again.